Okay, we've worked some problems where we were given the explicit formula and we were given the recurrence relation. Now, we're going to work with sequences. So working with these sequences, we are going to find the next two terms. This is all about patterns, patterns. Then find the recurrence relation. Then we're going to find an explicit formula. All right? Okay, let's do it. Here we have A is A sub n is equal to -2, 5, 12, 19. So the first thing we're looking for are the next two terms. So from these next two terms, ... what comes next? What pattern are you seeing happening here? How did I get from -2 to 5? From 2 to 12. Pardon me, from 5 to 12. From 12 to 19. Yes, you're going to add 7 every time. That's what we're looking at, right? Plus 7 to get there, plus 7 to get there, plus 7 to get there. So if I know I'm adding 7 every time, what's going to be the next two terms? Plus 7 to get there is going to get me a what? 26, good. Plus 7 to get to the next one is a what? 33. There's my next two terms. And it's helpful to find those next two terms because now I'm finding the pattern to get there, right? That's the key. Okay. Now here's the beauty of that. When you find the pattern to get there, what happens with a recurrence relation? Yes, you build off the next one, right? That's the whole point of the recurrence relation, is I'm building off of the previous term. Well, what am I doing to build off of that previous term? I'm adding 7. So that's how you build a recurrence relation. So A sub n plus 1 equals my current term plus 7. Now remember, every single time you have a recurrence relation, you have to start with the given value. I'm starting at 0. Woo, woo, woo. I'm making these noises so you pay attention. I'm starting at 0 of my n. So n is equal to 0, 1, 2, 3. Remember I said we were going to start with 0 here? Not start with 0 as my term. Start with 0 as my n. I'm sorry, I wasn't very clear at first. My first term is given to me. So that always goes right here. Yeah. Does that make sense more now? Okay. So my n equals 0. My n value, I'm starting at 0 because it's going to be helpful with our explicit formula. So here's what we're doing now. I have A sub n. Now you tell me, when you have, I'm going to write explicit formula here, just so you can see the difference. Now you tell me, what does it mean to have repeated addition? What is that? Yes, multiplication, right? Multiplication is repeated addition. So if I'm going to add 7 to the previous term every single time, that's the same thing as 7n. Now the real question here is, how do I get this very first term of -2? Oh, do you see why we love this? If I plug a 0 in here, 7 times 0 is 0, and I just subtract 2 from that, bam, first term. Yeah, sweet, right? So that's why we use 0 to begin with. You don't have to, right? You can use something else. What happens if, just, for fun, what if I have A sub n and I'm using 1 as my first term? How's that going to be affected? I still know it's repeated, but the question is, what are we starting with then? Yeah, right? So I'm saying if I plug a 1 in here for n, 7 times 1, what do I have to add or subtract to 7 in order to get -2 as my first term? -9. Exactly, right? So if I were to take this 1 and plug it in here, 7 times 1 is 7 minus 9 is -2. Then try my 2. 7 times 2 is 14. 14 minus 9 is 5. right? So it's nice to check a couple of them down the line just to make sure that the pattern holds. And in this instance, it does. I like to start with 0 because that's my initial value and it's always going to be added or subtracted as my first term. That's nice, right? Yeah, it really is. Let's do another one. Same thing, we're going to do all 3 here. I'm going to put a line here because there's a lot going on. So I have a sub n. My sequence is 3, 6, 12. I got in a mode, didn't I? 3, 6, 12, 24, 48, etc. What are you doing to get to that next term? Yeah, you are multiplying by 2, right? 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. So it stands to reason that my next 2 terms in the sequence, what's 48 times 2? 96. Now, what's 96 times 2? Don't get too worked up about that. 6 times 2 is 12, carry the 1, right? And then 9 times 2 is 18, plus 1 is 19. You can still do that in your head. You don't have to have a calculator for that. You can still pull that off. But there's my next 2 terms because I'm multiplying by 2. All right. So we have our recurrence relation. Remember, the nice part about, I'm going to scoot this up, the recurrence relation is that it builds on the previous term. So what did we say we were doing? Multiplying by 2. Okay. So a sub n plus 1 equals 2 times a sub n. And I'm starting my very first initial value here with a 3. Good, because that's always the first term. And then you have to identify n. So we didn't talk about this last time. Well, we talked about it, but I didn't make it a big point. Here's the kicker to these. You have to, for a recurrence relation, have this a sub n plus 1. You have to have an initial value. And the value here has to be the same initial value here. If you start at a sub 1, that's fine. You can call it that. You can call it a sub 1 all day long. As long as you have 1, 2, 3, and you go from here. It doesn't matter to me. All right? I like to start at 0 because it's easy. That's it. That's the only reason. Simply because I find it easier. And it's kind of standard also. Explicit formula. Now, we found out that repeated addition was multiplication. What is repeated multiplication? What's that called? An exponent. Yeah. Man, you guys are astounding. So a sub n. So I know this is going to be 2 to the n. But here's the kicker. I am saying if I start at 0 because it makes my life easy, what happens when I have n as a 0? What's 2 to the 0 power? 1, right? Anything to the 0 power is 1. So if I'm going to take this, how do I get a 3? We could add 3. Let's try that. What if I add 3? So then a sub 0 would be 3. What about a sub 1 then? I have 2 to the first plus 3. That's a 5. That's not what I need, right? Ooh, okay. Let's try something else. Adding 3 is not going to work, and that's why you try stuff. What else is an option? What if I multiply by 3? Okay, let's try it out. A sub 1 is going to be 3 times 2 to the 0, which is 3. A sub 2 is going to be 3 times 2 to the first, which is 6. And a sub 3 is going to be 3 times 2 squared, which is 12. And lo and behold, we've got it, right? Okay, so this is going to be our explicit formula. Again, with that explicit formula, you have to identify n. If I'm starting here at 1 instead, that's going to change this whole formula. I have to have something, and that's why we try some things out. That's going to get me my sequence by plugging these values into the formula. In order to have a legitimate recurrence relation, you have to have the a sub n plus 1, your formula with an a sub n, identify the first value and the n's. You have to have for an explicit the actual formula and identify those n's. All right, there's pieces in a sequence that you have to have for it to be valid. Okay, cool, but it's not too bad.